This is Geek Gardener, and in this video we're going to talk about measuring instruments used in hydroponics. When it comes to instrument, there are only two main things that one need to worry about: the pH meter and the EC meter or the TDS meter. So the internet is in splits whether to use the EC meter or the TDS meter for measuring the concentration of the solution. But before going into deciding which one to use, you need to understand what both of them are measuring. They're one and the same, but the way it is being displayed is different. So let's understand pH meter. pH meter measures the acidity or the alkalinity of the solution. And there is only one meter that measures that, so that's out of the way. A TDS meter or an EC meter essentially measure the concentration of salts in a solution. So which one to choose? So exactly why we need to understand what they do. So we all know pure water does not conduct any electricity. So when you add a little bit of salts, these ions in the solution conduct electricity. More the ions, more electricity is conducted. So electrical conductivity is the nature of the solution to conduct electricity through it. So the concentration is higher, more electricity is conducted. If the concentration is very dilute, less electricity is conducted. So all the EC meter or pH meter, if you really observe, I have one with me, you'll see that there are two electrodes in the meter. So they are separated by exactly 1 centimeter. So they pass electricity to one and then they measure the electricity on the other. And based on how much of electricity is conducted, we get a meter reading saying, you know what, your concentration is this much. So, okay, now which one should I go for? A TDS or an EC meter? So, an EC meter directly measures how much of electricity is conducted. So, there is no conversion into number of salt or number of grams or anything like that. So, whatever you measure in the EC meter, that is the amount of electric charge conducted. The unit of measure for electrical conductivity is Siemens per meter. So all the units, Siemens is a very high quantity. So to handle our dilute concentration, it is usually millisiemens or microsiemens. A TDS meter also measures conductivity, but it's not expressed so. What TDS stands for is total dissolved solids or total dissolved salts. So it shows what is being measured. So you want to know what is the total amount of solids or salts dissolved in the solution. So the unit of TDS is milligram per liter, or this much amount of salt dissolved in, say, a liter of water. And it is also expressed as ppm, parts per million. 1 part of salt for a million parts of water. So that essentially translates to 1 milligram of salt in 1 liter of water will make 1 part per million. So that's the way to easily remember a ppm. 1 ppm means 1 milligram of that salt in 1 liter of water. So which one to use is still a question. A TDS meter measures amount of ppm in the water. So it essentially means if it reads 200 ppm, it means 200 milligrams of salt is in the water that you're testing. If it is 600, it's 600 milligrams per liter of water. So the confusion arises when you want to use it, when you want to use the meter, but whatever book you're referring to or whatever internet article you're referring to mentions this is the concentration in EC, but you have a TDS meter, or vice versa. A TDS meter is essentially an abstraction over EC. So what they did was to measure exactly how many milligrams of salt is in the solution. They take a standard salt, say for example sodium chloride, which is a common table salt. Put say 1 gram of salt into a liter of distilled water and measure how much of conductivity it has. So now 1 gram of salt should have this much conductivity. So you can build a table like this and then it can be converted between EC and TDS. This is for sodium chloride. There is also another standard for potassium chloride. For TDS, it is always measured with reference to a single salt. So it is always sodium chloride or potassium chloride is the standard with which the nutrient solution is measured. While it is okay for most of the cases, the nutrient solution has a cocktail of salts, sometimes 10 to 12 salts. So it cannot be always arrived at exact value based on your single standard salt. And your ppm meter may have a sodium chloride calibration, and the other TDS meter could be a potassium chloride calibration. So both the meters measuring the same solution can give you different values. And hence, it is always advisable to go with an EC meter so that you have one absolute value regardless of where you are, which company's instrument you're using. So from now, we're going to dedicate this rest of the video on using an EC meter. We are not going to use a TDS meter, so we'll stick to EC meter. So I have an EC meter with me right now. Practically any EC meter should work. I'm using a brand called Aqua Pro from this company called HM Digital. I've been using this for a while and it seems to work. So this is, you have two electrodes in the bottom. That's the part that senses the solution, and it is battery operated. So as long as you keep it in a good place, it can come for another year or two. So we are going to demonstrate the usage of this by actually making a nutrient solution and adjusting the conductivity for it. So for example, right now I'm powering it on. It shows 0 microsiemens. The model is Aqua Pro 2. There is another model called Aqua Pro 1 that is a TDS meter. Okay, so we want to use EC meter for hydroponic nutrient management purposes. So to demonstrate the usage of this, I'm going to make a nutrient solution of 1 liter using RO water as a base water. So it is a good idea to check your base water's conductivity first before you add nutrients to it, and that's exactly what we're going to do. So I'm measuring the conductivity of this. There is a button called hold button so that you can measure it and then press hold, and it's going to remember the solution. This is 33 microsiemens, and I'm not sure if you can zoom it in here. So this is 33 and it's on hold. And also remove the hold mode when you dip it in next, otherwise it's going to show the same number every time. So this is RO water. It's going to be under 50. So now what we are going to do is, I have part A and B, which we made in one of the previous videos. It's a 2-part nutrient solution, and you need to add both the parts in this. You need to add both the parts in the same volume to achieve the required concentration. So we are growing lettuce, spinach, and all those green leafy vegetables, for which I usually like to keep the conductivity around 1200 to 1400. So we are going to adjust this to that range. So let's start by adding 5 ml of part A and 5 ml of part B into the solution, and then see how it affects the conductivity. So I have a small 10 ml measure. I'm going to measure about 5 ml of A and B just to show you how the rise in the EC is after adding these two to this 1 liter of RO water. So just follow me in this. So I have 35 ml of A. I have a stirrer also. Just stir it. Now I'm going to add 5 ml of B. 5 ml of solution B. I've added this. Stir it well. And now I'm going to measure. So it reads 0. It's removed from the hold setting. Now, the reading I have is 1234 microsiemens. You want to convert it into millisiemens, you have to divide it by 1000, which is 1.2, which is exactly in the neighborhood of where we wanted this to be, 1200 to 1400. Also, another addition is plants don't take a specific number, they always accept a range. So if you were to adjust this for 1.2, it is okay to do it at 1.3 or 1.2. In that range is okay. In this attempt, we managed to get it to the exact required state in the first go itself. But reality is not always like this. You may want to also add a little more. You may want it to be 1400 microsiemens and it will only be 1200. So what I want to show you is how to add very small quantities of A and B to just fine tune your measurements to say 1400. So for that, the quantity I have is only 1 liter. So there is a very small room for errors. So we want to use a very small dropper like this to adjust. But if you have a tank of say 500 liters or 1000 liters, then you can add in mugs or in beakers like this and get the correct correction done to the conductivity of the solution. So for example, this is a 1 ml dropper. So I'm going to add just 1 ml of A and 1 ml of B. So this is approximately 1 ml. So I added that. Remember, you need to always add the equal parts of A and B because all the nutrients present in that are all in a specific ratio to each other. By not mixing, you will have, by not adding the equal parts, you will have imbalance in the so I'm going to add part B as well. Now mix it well. Okay. So now we had 1, 2, 3, 4, approximately 1.2 millisiemens. Now we added an ml of each, part A and part B. We're going to see what is the increase in the EC. Okay, so now the value is 1414, 1414. Okay, so by adding another ml of each, we were able to arrive at a perfect value that we wanted to be on the higher end of the range. 1.2 to 1.4 is what we wanted to get to, and we have reached. And this is how you finely adjust the nutrient solution to the desired range. There is also one thing we need to understand. We were increasing the conductivity, so it was easy for us to add A and B. But there are times where you would have added more, or you already a system with the nutrient solution where water has evaporated and the concentration is much higher than what you want it to be. In such cases, we are not going to add any nutrition. We are going to reduce the concentration of that solution. So in that cases, what we need to do is add plain water to it. In our case, we are using RO water as a base, so we'll add more RO water to reduce the concentration. In your case, adding RO water reduces the concentration faster than adding a hard water or a tap water, because tap water already has some salt. So that's how you go about reducing the concentration. You increase it by adding equal parts of A and B, and you reduce it by adding plain water to it. Now we're going to watch how to reduce the conductivity of an already existing solution. You may ask, when will this happen? If you have a growing system, the plants consume nutrients at a different pace. On a hotter days, they consume more water, so you will have the salts left behind in the solution. So on these days, you will find the water level has gone down in the tank or the reservoir, and then your EC has gone higher. You may not want to add more nutrition solution to a solution that is already having a higher conductivity. What you want to do is to reduce the conductivity to the required range. In the case that we discussed, it could be 1.2 to 1.4 millisiemens. So what do we do in that case? How do we bring the EC down? We looked at how to increase the EC. Now we're going to watch how to decrease the EC. Now I have a solution, which is, I'm going to measure it right now. It's 1420 approximately. Another thing that I get asked more often is how deep the probe should be dipped. So there is a cut. This is the mark up to which the probe can go. Any lesser you dip, you are going to get an erratic result. So always dip it till the cut. So I'm getting about 1396 to 1400. Let's say it's 1400. Now we want to bring it to 1000, for example. How do we do that? So we always add water back into the solution to reduce the conductivity. So we're going to see how much to add so that it comes down. So we're going to add gradually. We don't want to add water and then the EC goes way down and they need to add nutrient solution. So that's not what we want to do. I have plain RO water with me. I'm going to take about 100 ml right now. Again, stir it well. Now I'm going to measure. Now my value is 1200 something. So adding 100 ml reduced it from 1400 to 1200. So I'm going to add another 100 ml to bring it to 1000. It has come to 1100 something. So we can add maybe another 50 ml to see if it can come down further. So I'm adding 50 ml to So it is 1081. If you convert it into millisiemens, it's 1.081. So I'm okay with this range because it's the changes are very minimal here. But if we want to go ahead and add another 50 ml, we can do that as well. But you get the idea. To increase, you add equal parts of A and B. To decrease, we add water. So that's how you manage the nutrient solution. If you have a larger volumes, say 2000 liters, 5000 liters, it's good to take a sample out and measure in that sample and instead of directly dipping into the tank, because mixing a smaller volume is easier, whereas handling a larger volume is difficult. So the mixing takes time, everything takes time. So we will also look at all those strategies on how to handle larger tanks in another video to come probably in the next few weeks. So I hope you enjoyed watching this video and you understood what is EC, what is TDS, and how to use a conductivity meter to increase or decrease the conductivity of the nutrient solution. If you have any questions or need any clarification on any of that we have discussed, please write in the comments and I'll be happy to answer that for you. On the next video, we're going to watch about pH meters. What type of meters, what are buffer solutions, how to calibrate a pH meter, everything you ever wanted to know about pH meters in hydroponics. Stay tuned and don't go away.